What is a dynamometer? A dynamometer is a device used to measure torque, power, or force. It is an essential instrument in mechanical engineering used to characterize the performance of various rotating machines such as engines, motors, and turbines. So, about classification of dynamometers. Dynamometers can be categorized in two main ways, by what they measure and by how they function. By measurement type, we have torque dynamometer, specifically designed to measure the rotational force torque applied to a shaft. And power dynamometer, a more advanced version that measures both torque and rotational speed simultaneously to calculate the total power output. And by operating principle, we have friction dynamometers. These use physical friction between two surfaces to create a load. They are simple and inexpensive, but suffer from wear and tear due to physical contact. Okay. And a Peroni brake dynamometer is a simple mechanical device used to measure the power output of an engine or motor by absorbing energy through friction. It is one of the oldest types of dynamometers and operates by applying friction to a rotating shaft and measuring the resulting force. Construction of Peroni brake dynamometer is pulley. Actually, it consists of the following components that you can say. Pulley, wooden block, bolts and a spring, lever arm, counterweight, load weight, and stop. At first, the engine or motor rotates the pulley. The wooden blocks press against the rotating drum due to the bolts and springs generating friction. This frictional force applies torque under lever arm. A counterweight balances the system, and a separate weight at the end of the lever arm provides the required force. The torque is measured by multiplying the force exerted by the weight and the lever arm length. And at last, the power output of the engine is then calculated using torque and rotational speed. So, hydraulic dynamometers. They use the resistance of a fluid, such as oil or water, to create a load. As the engine spins, it moves the fluid, creating drag. And eddy current dynamometers, these use electromagnetic induction. A magnetic field is applied to rotating conductive part, creating eddy currents that generate resistance. And we have electric, AC or DC dynamometers. These utilize an electric motor to apply a controlled load to the machine being tested. So, here we have table, friction, hydraulic, eddy current, and electric, and the principles. But what about the loading, concept of loading? In engine testing, loading refers to the application of a resistance torque to the engine's crankshaft to simulate real-world operating conditions. No load condition, free running, full load condition, maximum load, and partial load condition, transient or variable load. And what is methods of applying load? Depending on the type of dynamometer, the load is applied through different physical mechanisms. Friction braking. Load is generated through mechanical friction between a brake pad and rotating drum or disc. An eddy current loading. Load is generated by inducing eddy currents within a conductive rotor placed inside the magnetic field. The interaction between magnetic field and the induced currents creates a resistive torque. Hydraulic loading, load is generated by the viscous drag or flow resistance of liquid passing through turbine or around lanes. And electric generative loading, the dynamometer acts as an electric motor generator. When loading, it operates in generator mode, converting the engine's mechanical energy into electrical energy.